Okay, so this is exploration 4 for 8th grade, analyzing the different energy that can be found in a system. Now we know for sure kinetic is moving energy and potential is the energy before movement. So now they're talking about how throwing a ball, when you're holding it in your hand, that's potential energy, but once it's being thrown, it's kinetic. So it can have both. Okay, why the amount, type, and form of energy might be the different or the same. Okay. The amount of energy might be the same because the potential that the energy could have might be the same as the energy that is shown when you throw it. The ball that you throw could go the same distance as the next one you throw. Or the other idea is that it might go further or not as far, depending on the energy and work. This means potential energy and kinetic energy can be the same or different. Right? It could be the same, but it could also be different depending on how much force you're using. Energy is not created or destroyed, but transferred. So you see this roller coaster car, it's moving. It had potential energy at the top when it was not moving, and then it went down the hill. So it was a mix of potential and kinetic. Roller coaster cars move slowly at the top, so they have very little energy, kinetic especially. The speed of the car as they move increases that kinetic energy. Well, where did that come from? Okay, kinetic energy was added by people riding in the cars. Well, the change of people in the cars, it didn't add anybody at the top. So that doesn't work. Cars always had kinetic energy. Yes, but that doesn't explain why there's additional. Potential energy can be transformed into kinetic energy. That's correct. So I chose that. Kinetic energy was added by a motor pushing the car. So if you notice, there's no motor pushing the car, so that would not be the correct way. Okay, so energy transformations, they're talking about how energy transfers from one to the other. Rolling ball hits another ball, and then the second ball starts rolling. So we've all seen that when we play basketball or different sports that involve a ball. To light a match, you rub the match head on a surface and then the match burns. Describe what's happening. So the match has potential and kinetic energy. When that potential energy is transferred to the surface, movement of kinetic energy combining with the potential energy of the surface creates more kinetic energy that does work on the match to light the match. Okay, so you've got the potential energy of both, and then you're moving the match. So the movement is the kinetic energy that's causing the kinetic and potential to transfer with the potential energy of the surface. And when they come together, that's the work that creates the friction that lights the match. So they're talking about an asteroid, and when it falls to Earth, that it has potential energy and kinetic energy. And the speed can increase and increase as it moves, which creates more kinetic energy. It also has like different types of energy. So like we talked before about electrical energy, The asteroid actually has thermal energy that can transform into light because it uses thermal and electromagnetic energy. Okay, so all that energy, when it hits the land, all of it is transformed into thermal and sound energy that moves into the rock and wherever the ground that it landed in. So it's talking about how asteroids can create wildfires because of thermal energy, and earthquakes because of the sound energy. And if the kinetic energy transfers into water, can also produce a tsunami. So interestingly enough, this orange streak, that is melted rock that happened, and liquid rock that went into the cracks because of an asteroid impact. Okay, so we're watching about rocks in the water. So if we have a bigger rock, as you can guess, there'd be a bigger splash. So the kinetic energy of an asteroid depends on the mass, and haven't talked about height at all, so it has to be speed. An asteroid has more kinetic energy, and if it does, it will transfer more energy to the Earth and throw more matter into the air. The faster it's going, the more energy that's going to be transferred. More ejecta will be thrown in the air. To conserve energy, roller coaster is kind of like that. You go up to the top of the roller coaster, that potential energy and kinetic energy come together, and then they are conserving that energy to output as soon as you start going down the hill. Body conservation of energy, so maybe you eat food, but it converts into energy, but it's conserving the energy for when you really, really need it. Okay. So hands-on lab we're not doing right now because we're not back in class yet. If your teacher asks you to do it at home, we'll be doing it independently together because you'll have different data than others. Describing energy in a system. Imagine that you are the energy associated with an object. So if we have to take a bike and it's pedaling down a mountain or a bowling ball, describe the change from one energy to another. So let's use a bowling ball. The mechanical system I chose was a bowling ball going down a lane. The potential energy is the bowling ball when it is in your hands. Then work is put on the ball when it moves, and that is kinetic energy. When it hits the, okay, so this has, it's when it is potential energy, that's when it was gaining energy. So it is gaining energy. And the movement of kinetic energy is conserving energy. That is using and conserving energy. When it hits the pins, it is transferring its energy to the pins. So that is how energy moves from one object to another in a system, right? It starts here, its potential has a lot of energy, gains energy, and then when the ball is moving, there's kinetic energy and it transfers the energy to the pins. Okay, taking it further. I think I want to know the energy of a yo-yo. Person playing with a yo-yo is a system. Research a yo-yo. What are the parts of a yo-yo? Okay. How does a yo-yo use energy? I love explain that stuff because it's using science to explain. Yo-yo's in your hand, it has potential energy. When it's released, it becomes kinetic energy. And it's constantly exchanging the energy. All right. So let's write that. When the yo-yo is in the hand, it has potential energy. When it is being thrown, it is using and transferring kinetic energy. The energy changes back and forth on the string to keep the yo-yo moving for as long as energy is being transferred back and forth from the two parts of the yo-yo, the string, and the shell. All right, so it's taking those two parts like we looked at, and it is exchanging them. It becomes a certain height and it's spinning, and it get more energy with the tug of the string. So let's add that too. More energy is added with every tug of the string. That kind of shows how it's able to transfer energy because it has potential, and then the kinetic energy goes back up, and when you tug it, even more energy. All right. Okay, so we're going to do self-check. Because you chose energy of the yo-yo, you don't have to do traffic, safety, and energy or the hands-on lab. We're not proposing our own path at this point. So we'll continue with a new video for the lesson self-check.